The last glacial maximum was the last period in the Earth's climate history during the last glacial period when ice sheets were at their greatest extension. Growth of the ice sheets reached their maximum positions 26,500 years ago. Deglaciation commenced in the northern hemisphere approximately 19,000 years ago, and in Antarctica approximately 14,500 years ago, which is consistent with evidence that this was the primary source for an abrupt rise in the sea level 14,500 years ago. At this time, vast ice sheets covered much of North America, northern Europe and Asia. These ice sheets profoundly affected Earth's climate, causing drought, desertification and a dramatic drop in sea levels. It was followed by the late glacial maximum. Glacial climate. The formation of an ice sheet or ice cap requires both prolonged cold and precipitation. Hence, despite having temperatures similar to those of glaciated areas in North America and Europe, East Asia remained unglaciated except at higher elevations. This difference was because the ice sheets in Europe produce extensive anticyclones above them. These anticyclones generated air masses that were so dry on reaching Siberia and Manchuria that precipitation sufficient for the formation of glaciers could never occur. The relative warmth of the Pacific Ocean due to the shutting down of the Oishio Current and the presence of large east-west mountain ranges were secondary factors preventing continental glaciation in Asia. All over the world, climates at the last glacial maximum were cooler and almost everywhere drier. In extreme cases, such as South Australia and the Sahel, rainfall could be diminished by up to 90% from present, with flora diminished to almost the same degree as in glaciated areas of Europe and North America. Even in less affected regions, rainforest cover was greatly diminished, especially in West Africa where a few refuges were surrounded by tropical grasslands. The Amazon rainforest was split into two large blocks by extensive savanna, and the tropical rainforests of Southeast Asia probably were similarly affected, with deciduous forests expanding in the place except on the east and west extremities of the Sunderland Shelf. Only in Central America and the Choco region of Colombia did tropical rainforests remain substantially intact, probably due to the extraordinarily heavy rainfall of these regions. Most of the world's deserts expanded. Exceptions were in what is now the western United States, where changes in the jet stream brought heavy rain to areas that are now desert and large pluvial lakes formed, the best known being Lake Bonneville in Utah. This also occurred in Afghanistan and Iran, where a major lake formed in the Dasht-e Kaveh. In Australia, shifting sand dunes covered half the continent, whilst the Chaco and Pampas in South America became similarly dry. Present-day subtropical regions also lost most of their forest cover, notably in eastern Australia, the Atlantic forest of Brazil, and southern China, where open woodland became dominant due to drier conditions. In northern China, unglaciated despite its cold climate, a mixture of grassland and tundra prevailed, and, even here, the northern limit of tree growth was at least 20 degrees farther south than today. In the period before the last glacial maximum, many areas that became completely barren desert were wetter than they are today, notably in southern Australia, where Aboriginal occupation is believed to coincide with a wet period between 40,000 and 60,000 years before present. World impact. During the last glacial maximum, much of the world was cold, dry, and inhospitable, with frequent storms and a dust-laden atmosphere. The dustiness of the LGM atmosphere is a prominent feature in ice cores. Dust levels were as much as 20 to 25 times greater than at present. This was probably due to a number of factors: reduced vegetation, stronger global winds, and less precipitation to clear dust from the atmosphere. The massive sheets of ice locked away water, lowering the sea level, exposing continental shelves, joining land masses together, and creating extensive coastal plains. Europe. Northern Europe was largely covered by ice, the southern boundary of the ice sheets passing through Germany and Poland. This ice extended northward to cover Svalbard and Franz Josef Land and northeastward to occupy the Barents Sea, the Kara Sea and Novaya Zemlya, ending at the Taimyr Peninsula. Permafrost covered Europe south of the ice sheet down to present-day Szeged in southern Hungary. Ice covered the whole of Iceland and almost all of the British Isles but southern England. Britain was no more than a peninsula of Europe, its north capped in ice, and its south a polar desert. Asia. There were ice sheets in modern Tibet as well as in Baltistan and Ladakh. In Southeast Asia, many smaller mountain glaciers formed, and permafrost covered Asia as far south as Beijing. Because of lowered sea levels, many of today's islands were joined to the continents. The Indonesian islands as far east as Borneo and Bali were connected to the Asian continent in a landmass called Sundaland. Palawan was also part of Sundaland, while the rest of the Philippine Islands formed one large island separated from the continent only by the Sibutuan Passage and the Mindoro Strait. Africa and the Middle East. In Africa and the Middle East, many smaller mountain glaciers formed, and the Sahara, Gobi, and other sandy deserts were greatly expanded in extent. The Persian Gulf averages about 35 meters in depth and the seabed between Abu Dhabi and Qatar is even shallower, being mostly less than 15 meters deep. For thousands of years the Urshat provided fresh water to the Gulf, as it flowed through the Strait of Hormuz into the Gulf of Oman. Bathymetric data suggests there were two paleo basins in the Persian Gulf. The central basin may have approached an area of 20,000 square kilometers, comparable at its fullest extent to lakes such as Lake Malawi in Africa. Between 12,000 and 9,000 years ago, much of the Gulf floor would have remained exposed, only being flooded by the sea after 8,000 years ago. Australasia. The Australian mainland, New Guinea, Tasmania and many smaller islands comprised a single land mass. This continent is now referred to as Sahaland. Between Sahalan and Sundaland, a peninsula of Southeast Asia that comprised present-day Malaysia and western and northern Indonesia, there remained an archipelago of islands known as Wallacea. The water gaps between these islands, Sahalan and Sundaland, were considerably narrower and fewer in number. North America. In North America, the ice covered essentially all of Canada and extended roughly to the Missouri and Ohio rivers, and eastward to Manhattan. In addition to the large Cordilleran ice sheet in Canada and Montana, alpine glaciers advanced and ice caps covered much of the Rocky Mountains further south. Latitudinal gradients were so sharp that permafrost did not reach far south of the ice sheets except at high elevations. LGM glaciers forced early human populations who had originally migrated from northeast Siberia into refugia, reshaping their genetic variation through mutation and drift. This phenomenon established the older haplogroups found among Native Americans, whereas post-LGM migrations are responsible for northern North American haplogroups. On the island of Hawaii, geologists have long recognized deposits formed by glaciers on Mauna Kea during recent ice ages. The latest work indicates that deposits of 3 glacial episodes since 150,000 to 200,000 years ago are preserved on the volcano. Glacial moraines on the volcano formed about 70,000 years ago and from about 40,000 to 13,000 years ago. If glacial deposits were formed on Mauna Loa, they have long since been buried by younger lava flows. South America. In the southern hemisphere, the Patagonian ice sheet covered the whole southern third of Chile and adjacent areas of Argentina. On the western side of the Andes, the ice sheet reached sea level as far north as in the 41 degrees south at Chasseut Channel. The western coast of Patagonia was largely glaciated, but some authors have pointed out the possible existence of ice-free refugia for some plant species. On the eastern side of the Andes, glacial lobes occupied the depressions of Senor Skyring, Senor Otway, and Neutral Bay and Beagle Channel. On the Straits of Magellan, ice reached as far as Segunda Angostura.